Hello, everyone. Welcome to the National Cybersecurity Association webcast series. My name is Gustavo Hinojosa, Director for the National Cybersecurity Student Association. Today's presenter is Vitaly Ford, and his presentation topic is GenCyberCoin, Development Journey of a Gamified Cybersecurity Web Platform. Let Vitaly take it from here.
All right, thanks, Gus. So this platform I'm going to talk about, I've been working on since I was in grad school about 3-4 years ago. I think I started. Right now I teach at Arcadia University for the 3rd year. And this project focuses a lot on not only just cybersecurity topics, but also some little bit of ethics, a little bit of password management, and some links are included there, some videos where you can show your students how effective zero attacks are and what may happen if those are executed by hackers. And all of this just available for free currently and forever, I guess. It's hosted on GitHub. I think we have a question in the chat. Hey, everyone. Yeah, oh yeah, it was Gus. Yeah, so we have available on GitHub. I have all kinds of instructions here, depending on what kind of system you want to deploy it to. It is already deployed on Amazon. I'm going to go over that today and how that development journey started and how I moved from Docker containers to Amazon, from Amazon, I'm thinking right now to Heroku, and what kind of technology I used to actually develop this stuff. And maybe in the future, it would be useful for some of you to actually spin up something like that or have some kind of contribution to maybe even this project. So you can see that for this project, we have, as I already told you, lots of different instructions. You can install it locally on AWS. You can also set it up as a Docker containers with a Docker Compose. Just run one script, and it's all going to be done and running on your machine without installing anything else besides just these 2, sometimes 3 software. And I also have at the very bottom, Hall of Fame. This is the students. These are high school students who actually contributed in finding real bugs on the platform. This platform does have some bug bounty program where students can find stuff. And as a result, lots of them try to actually literally break stuff. And some of them did find a way how to do this. So I put their names there. I want to start today with maybe introducing how it works, the platform itself, then moving on to the code, the technology behind it. It's written in Python primarily. I'm going to show you some logs. I always get some attacks, just bot attacks. Typically, it's just enumeration for PHP scripts, some kind of shells, and obviously because everything is written in Python, none of those get a response back to hackers. And the primary, even though the primary language is Python, there is still some JavaScript and a front end. And obviously I used a framework for the front end. I used Bootstrap, which was the easiest one at that time, at least. And let me start, before I actually move on to this stuff, let me start with showing you how it's going to work. And just a few months ago, I did not have this feature yet, but right now I do, which is a trial check mark. Before, you had to actually contact me to register on this platform and get stuff running as a, say, I don't know, admin or somebody else. Right now, you have this trial button that allows anybody in the whole world to just log in and play around with stuff. So let's say I'm going to create a new account. My name is this, password, answer. This doesn't matter technically. And now I'm going to set a trial. So submit. And you get to this place, right, where you can see your password management, account details, blah, blah, blah. If you go to wallet, you can see that you have some money going on already. You can redeem your reward codes. You can send money to somebody. But the trial actually generates a school name given the IP address. So unless you have somebody connected to the network on the same IP address, for instance, you're running in a classroom environment from your university or high school, unless that is the case, people will have different IP addresses. As a result, they will be placed in different rooms. So you can see also market items, and those are obviously security related, somewhat, but you can add to cart. Obviously, you're not going to get it, but they can be used for cybersecurity camps, like GenCyberCamps. That's where actually GenCyberCoin is coming from, right? And people could put real items, and then students, as they compete, they would be able to earn coins and actually get those items, physical items. Now, right now, this market exists for the whole purpose of bug bounty, which students, when they logged in, right, go to bug bounty, they can see there are currently 18 different bugs that can be found on this system. There are some links to learn about some interesting facts and stories that happened over time. And you can also see that there are some reconnaissance questions. That is a list of questions that students can use, maybe Google, maybe just knowing something, have to look at specific YouTube videos and have the answer. And as they respond to this stuff, they actually get coins automatically. As they find bugs, they get coins automatically. And then everything gets propagated through. They can see how many people answered questions, blah, blah, blah. So then you have leave feedback as well. There is some bug bounty hidden here. So the system focuses primarily on the core of cybersecurity, which is confidentiality, integrity, availability, defense in depth, and keep it simple, and think like an adversary. So these are principles of cybersecurity, GenCyberCamps. And because this platform started from there, I still keep all those principles, and we try to apply those in this platform. On the cryptocurrency, students can learn about some nice facts, as well as take a look at the videos, how Bitcoin works, for instance, so learn about cryptography. And the biggest parts are probably bug bounty and reconnaissance, because that's where the action happens. Now, this is just a platform that is already available. The real fun part begins when we talk about deployment. And if you do have any questions, I guess you guys can either send it in the chat or maybe unmute yourself later on. We don't have too many people, so it will be possible, I guess, to chat about stuff here, how it all works. And you can always shoot me an email. But as I already mentioned before, it's all available on this website. You just click on register, select the trial button, and you are in, as well as your students. And if your students are running from the same exact campus, they all will be placed in the same exact room and can compete against each other. So let's start with this. I'm going to scroll a bit down and show you the AWS instructions. So right now I deploy it on AWS. Not sure if you're aware of this program, but there is this AWS educate.com that allows you to get free credits for your students and yourself as a teacher, for instance. Any school can sign up for it, including high schools, I believe. And there are lots of institutions served. They give you $50 credits per class. And plus, on top of that, for instructors, they give $200 credits per year as an educator. So it's lots of money to run any kind of stuff online, not only just deploying into, I don't know, this GenCyberCoin thing, but also databases, machine learning, and all other features that are available, Cloud9 on AWS, media transfer, I know, translate, video processing, all kinds of other stuff. So Amazon was pretty much available to me at that time, and that's why I decided to go for it. There's not that many things to do, even though it could seem like there is lots of instructions going on. And I want to show you what exactly it looks like on the back end right now. If I go to my Amazon console, I deployed it using Elastic Beanstalk, which automates deployment. All I have to do when I update my code is to say EB deploy, and the code is going to be uploaded automatically. Load balancer will pick it up and automatically distribute across all my current running machines in the cloud. Database will be updated, and all kinds of other things will happen also automatically. So I wanted to show you some interesting things. For instance, on the configuration on a Elastic Beanstalk, you will notice that it tells us there is one instance running, which is virtual machine. You can consider that. There is also this so-called load balancer, and load balancer has a capacity set. If I have more users, it will automatically create extra instances. And I set it up to 5 right now. I don't need more unless I really get DOS attack. And at that point, I don't know, I don't even need to spin up more machines because this project is educational. It's not production ready per se. So 5 machines is the max that I set it to balance the load among the users. If I have too many users, it will automatically increase it and decrease it depending on how many users are using it at any given time. This load balancer is set right here. You can also see at the bottom there is some security configuration and monitoring is done automatically by Elastic Beanstalk, which means that I will get an email if my server goes down. I get an email if my server gets DOSed. All kinds of other things are happening, right? And then database that is also available for access to get information from it, and later on fill up information for all the users on that platform. So that's what you have at the back end. Now, this is not maybe as fun as looking at the Docker container though, because as great Amazon is, I think the beauty of deployment and DevOps, which is development operations, is coming from containers. And some of you may know that the idea of containers is to combine a Linux kernel with a bunch of applications, libraries, frameworks installed all in one container and shipping it to remote users in such a way that to deploy all this stuff, users would have to only run one command. So that's the idea of these Docker containers. Docker Compose allows you to have multiple Docker containers and create networking, create automatically configurations, allow them to talk to each other. And we call this orchestrator. Some of those other orchestrators you can find online would be Kubernetes, which is very popular right now, but it's not really used for small projects. Typically, you would use that for quite large scalable projects. There are some other orchestrators that are very popular, but for local machine deployment, Docker Compose just do a great job and just enough. So let me open up code in Docker Compose, and I'm gonna probably start with that. What does that do? So you can see that in Docker Compose, I specify multiple containers. I call one container web, another one Nginx, another one Postgres. And I also used to have Redis, but then I decided I don't need any more of this database, in-memory database, so I commented it out. Maybe for future use, I will keep it. But I want to show you maybe on a picture right now and draw it out, how it actually works in terms of DevOps. So let's imagine you have a bunch of users coming in. Oops, I forgot to switch this to a pen. There we go. Zoom panel. Okay, there we go. That works. So you have a bunch of users coming in to your server that is currently getting processed, and it's called Nginx. So it processes all the requests. This is in our case, we call it a proxy. And Nginx/load balancer. Nginx could be used and is used as a web server. However, in our case, I'm using it as a proxy and load balancer. And the reason why, because it's very lightweight, it's fast, it does work pretty fast. And as a result, I thought it was a good solution. Plus, it was originally written by a Russian, so I'm a little bit biased to that. So you have Nginx load balancer running, and after that, your traffic from users is not getting processed, it's not getting any replies. All Nginx does, it tells next this traffic will go to web servers. And this is where you get to a point of splitting up your normal load to multiple web servers. So I'm going to put them in the red block. And those will be, for instance, Web 1, Web 2, and some kind of Web 3. Those would be running as separate instances. And they will be processed by software that is called Gunicorn. This is also lightweight, simple to use web server that can run Python. In our case, I'm using a Django framework, which I'll mention later on when we get to the code part. But Gunicorn will take your requests from the users that Nginx passes to this Web 1, Web 2, Web 3, depending on how many copies of the same exact web server we have running in the memory, right? It's going to pass those to the appropriate copy. Typically, it's done either as a round robin mechanism. So the first user will go to the first web, second user to the second one, the fourth one will go back to the first one, the fifth to the second one, and so on and so on. And sometimes those load balancers actually split it up to keep track, split up the packets depending upon how loaded every single web instance is. So they would keep track the processor load, Web 1, Web 2, and Web 3, and send the current user to the one that is less loaded. So it's all done by load balancers. And Gunicorn just picks up those requests and processes it, and then runs our code that will be later on visible here. And I'll show you exactly what I mean by Django as well. So Gunicorn takes care of the server side. The real question is what's going on next? Well, after Gunicorn, you're actually getting to play with something that we're going to call right now Redis. And I don't have it running, but I'm thought to mention it because it's useful for deployment and just to know what it is. Redis server allows you to do a few things. First, it's caching. Second, you can let these web servers to talk to each other and synchronize. So I'm going to just put a sync because otherwise they cannot talk to each other. They have to have some kind of database, and that's what Redis is. It's a database of key and value pairs. If you've taken data structures, you would know this is a hash table or dictionary. And that's what Redis is. It's in-memory dictionary of key value pairs that can be shared across all web instances that you're running. And you also can use that Redis server for other purposes besides just cache a web server. Maybe actually we'll stop at number 2. But I don't use it because caching-wise, I don't have too many images to cache with CSS, JavaScript, and plus your browsers will do that job for us. I don't use any kind of CDNs, which is a content delivery networks, and Amazon is famous in having very fast CDNs. Those are servers that cache, in other words, get information that is mostly used by lots of users and keep it on that site. So whenever a user passes a packet through that specific site, the server will respond with either yes, I have it in a cache, you don't even need to go and look for it, or no, I don't have it in a cache, move on and try to find it. So I don't use that here. I also don't need to do any kind of web server synchronization. I don't write any, in GenCyberCoin, we don't have any kind of real-time chatting mechanisms or maybe forum, I don't know, submission of asynchronous messages, all this stuff that typically would be written in Node.js. This is another language, right? It's JavaScript-based server. So I don't use that kind of stuff. That's why I decided not to use it. However, in a typical DevOps, you will most likely see Redis be used for these exact reasons that I just mentioned, cache and synchronization among the servers. So after web server, Gunicorn, we do have, though, databases. And databases, so Redis will be actually connected to all of these, right? And then you have database. In my case, I'm using Postgres. There was some reasoning behind picking up Postgres over MySQL or MariaDB, MongoDB, right, which is other NoSQL databases. There was a reason behind Postgres because I do have lots of relationships among tables. and tables define the data, right, that we're storing inside of our databases. So Postgres is famous to be fast. It's relatively, it's quite secure, I think, in my opinion, at least. And because it's fast and secure, it has a large community. I decided to go for it. And these web servers will be actually connected directly to this instance. Technically speaking, you don't have to make this instance publicly available on the internet. You can actually segregate it and let only web clients or web servers to handle users' requests through this database connection. But you can also leave it all open online if you want to try to get logs from your attacks, because it's always fun to see what hackers try to do with your server, especially if your server is educational and you don't care if it goes down or not, because eventually you can always have a backup. And it's always interesting to use that as a honeypot in a sense. There's lots of research done in honeypots. It's, oops, something went out. Come back, come back. Okay, my system froze. Give me a second. Okay, it's unfroze. Okay, took it a second. Ooh, coloring changed. So honeypots are intentionally vulnerable servers that allow you to log every single access and then send it over to a server that manages all this data and shows it, visualizes it, shows you the results of different types of attacks. So you can use that as your educational project, because first of all, you can see real users what they're doing, right? And second, it's always fun to see if people actually can break through your security mechanisms. And that's how you can also learn by adding additional layers, maybe fixing your bugs, because there are thousands of lines of code, and obviously we're people, so we write code with bugs. So that's why I kept my database wide open on the internet. However, it's not really a good security practice to do this in production ready software like startups or larger, smaller corporations. Don't recommend that. So anyway, that's how the system works currently, except the Redis part, right? Everything else, Nginx, Unicorn, running web stuff, and then database was shown in a Docker Compose right here. You'll also notice that Docker Compose builds containers, and it builds containers based on certain images. So images could be pulled from a Docker Hub, which is a wonderful place where people can custom made their software. They put it around some kind of frameworks. They test it out, then they insert it into Docker, make an image of it, and publish it online so that you can actually use it for free in your own environments. You can, in fact, run Linux, for instance, right? Right now on Windows, as probably some of you know. And Docker, technically speaking, is Linux, right? It's running Linux kernel in every single container. It doesnn't matter if it's Debian, Ubuntu, or Arch Linux, it's still going to be Linux. So it allows you to run a container that's going to run on every operating system, Macs including and Windows including. So it's very, very flexible. And if you take a look at building, for instance, we had a question. No. Oh yeah, recorded, posted. Does anyone run this? Oh, yeah, does anyone run the Raspberry Pi? Currently, I haven't run it in Raspberry Pi, but I don't see why you wouldn't be able to. However, I think running Docker in Raspberry Pi could be a bit tricky. So maybe you would have to go for deploying this on a local machine. I have instructions for that as well for local setup without any Docker containers. But currently it is running on AWS, and it uses Python 3 point something, 3.6, 7, or 8 all will work, and Python 2 will not. And it uses Django as a framework. Actually, speaking of this Django framework, what is this? I forgot to open this tab, so I'm going to open it right now. It's a great framework to play with. If you've done any web development before in PHP, I think you will really appreciate this framework, especially if you're into Python. Now, some people will argue that Django is not as fast as Node.js, and they will be absolutely correct. However, in a combination with such nice software as celery, for instance. Oh, no, I don't want a celery juice. Don't need to buy some vegetable. No, that's celery. Celery is a software. So in combination with celery, you can actually create very good written real-time applications, and they will be fast. So this introduces asynchronous task management in queue processing. And Django can do some stuff asynchronously, but obviously Node.js, the JavaScript version of a web server, is much faster with that kind of stuff. In fact, Django used to be used by corporations like Netflix. So if Netflix could handle all that load with Django, I'm sure we can do that as well. It's a very nice framework. The reason why I decided to go for it because of Python. I love Python. I think it makes your life much easier than any other language. I did program in JavaScript, but I don't really necessarily enjoy that as much as I do with Python. It is very fast. I have not seen any kind of problems whatsoever so far. It's very versatile. It's well developed. Community is huge. Documentation is excellent. It was super simple to create first apps. There are lots of nice tutorials on Medium, as well as just real Python and Django documentation as well. The official one, they have nice tutorials. There are also good stuff about this. Now, other people will say, well, why wouldn't you use Flask? Because that's another framework that is typically connected with Python. And the reason why I haven't used that, because I wanted to learn something. At that point, I did some programming in Flask, but I wanted to learn something new. And also Django is typically used in the medium-sized and large-sized projects. And even though GenCyberCoin, you wouldn't say it's a large-sized project, I still wanted to pick up something new. So that's why I decided 4 years ago to go for Django. So that was the reason. And guys, if you have any questions, by the way, feel free to ask as I ramble here about stuff. So all right, let's take a look at some code. Specifically, what are we building in a web, right? It's building something in Nginx, something in web, but what is it building? Now take a look at CryptoCoin, and this is a folder that Django project was called, CryptoCoin, and it has a nice file called Docker file. So this way we can see that how easy it is to create a container. In other words, a Linux distribution that runs as a process on your operating system and has all kinds of other software installed automatically for you. Right now, I'm showing you that this Docker container currently uses Python 3.7, some kind of slim version, right? It upgrades a Python package manager called pip. It copies the code from the current directory, which is a dot. Current directory is this one, right? The CryptoCoin directory, into a code directory inside of the container. And again, containers are just processes. However, Docker makes those containers to be Linux, almost like Linux operating systems. You can think of that. But it's not a virtual machine though. And because it's not a virtual machine and it is a process, it works much faster. So, and you can run some installation here and pretty much done. Look how simple that is. That file is very, very small. Now on Nginx side, this is our load balancer, right? It's even shorter. That's it. That's all I had to do, right? Then you connect those two pieces together and you tell that your web server will be dependent upon Postgres. You create some kind of volumes, and those are real files that are going to be located on your hard drive or SSD, whatever storage unit you're using, right, on your hard drive, and they will be automatically mounted to your to your Docker container. In our case, we are saving a web Django, web static, and web media inside of our web container. So these are just existing files and folders right inside of your real physical hard drive. But this stuff is virtual. So whenever your Docker container goes down, this stuff will be gone. But because it's automatically linked and mounted with a physical copy of it, even if you destroy your container accidentally, or maybe ransomware hits it, your data will be still intact. Very good stuff. And you can also back it up in case if ransomware hits you and encrypts everything. So that's another cool thing about containers. It's hard to escape container. It is possible. It has been done before, but it's still difficult. And you can also notice that the very last command inside of a web container is Gunicorn. That's the one that I told you that runs Python applications in the backend, right? You can see I'm telling it run with 2 workers. So just giving it 2 threads to handle all the requests. I didn't have to have too many there. And obviously, Nginx will be even shorter than the web. Web does the main work. Nginx just passes the traffic through. It just has a port opened, and it knows what kind of media and static files to serve, just in case if users do want to see those faster than requesting it from a web server. And then it links it with the web, so that makes sure that they can see each other and work with each other. And then you have a last one, which we call here Postgres. It's apparently based on an existing image of Postgres. And look how easy it is to actually get to images. You just go to Docker Hub, and you can search for an image, for instance, Postgres, right? And you're going to find lots of them. So somebody already created PostgreSQL database. It's up and running for you. You don't have to install anything. You don't have to, I'm going to use it a word, trash your system with extra stuff, right? You install it in a container. You run it for a few days, for a month, maybe for 2 months. If you don't need it anymore, it's super simple to delete. It's super simple to save. You can create your own profile and actually post your containers there, or images, sorry, not containers, images in your profile and make them publicly available. As a result, you can wipe it out from your system. And then later on, if you do need to use that exact Postgres with certain software and libraries installed, you can just pull it from your own repository, install it, Docker and Docker Compose, maybe Docker machine as well, and you're ready to go. It's going to even work on your grandma's or grandpa's computer, right? Without installing any kind of extra junk on their machines. So that's the wonders of containerization. And you can see I'm just basing off that image that I just showed you a second ago. And I'm telling that there is apparently some kind of PG data file that are linked with the data file inside of the Postgres container when it runs. That's pretty much it. Another interesting part of this configurator in Docker Compose, you can notice restart always. So if web server for some reason goes down, I don't know, DOS attack, or maybe resource overload, maybe some kind of things happen, I don't know, RAM got filled up and no space anymore and web server cannot run anymore, whatever else happened, right? Maybe tornado went through your computer and eventually you will be able to automatically restart it. All you have to do is turn on back your computer and Docker will pick it up and for you spin up this web, Nginx, and Postgres without even you doing anything. That's the beauty of this stuff, this restart always. So next thing I want to show you is the code, the Django code. And that's really cool how Django creates it. When you create an app in Django, and I call it an app because you can create multiple apps within a project. In my case, a project is called CryptoCoin, but the app that I'm using is called user app, right here. So within this app, I have lots of files, as you can see, but they're all separated into multiple directories. The most important files are located within views and templates. And then you have here and there some kind of static files, management, blah, 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 blah. Those are not that important. So views process your user requests. For example, if I open some kind of view account page, right? And take a look at change password, right? When I get a request and somebody is trying to change the password, I'm checking they're authenticated. I'm checking the password is password fields are set, and then I'm gonna update the user table. Some of you will actually be surprised that Django and Python in general has ways to do that as well. But Django framework actually abstracts communication with the database. In other words, you do not need to know SQL language, SQL, right? You don't have to know the language that is used typically to communicate with database. You can consider everything to be an object as if it was object-oriented programming. And you can see here, I'm actually getting an object from a table user that matches to the specific username defined by the requested account, right? And I'm setting a password for that user later on. And then if validation is successful, I'm gonna save it to the database. These lines literally talk to the database. They got the user, they updated the password for the user, and they saved it without any select statements whatsoever, any kind of weird injection points, right? We're actually avoiding here SQL injections automatically because Python takes care of that for you. You don't even need to worry about SQL injections anymore in this scenario. You still have to worry about some XSS injections, for instance, but that's on a different topic, talking about different topic. So anyway, that's how you would write code. You would just process it based on this variable called request that stores all information about the user, and you can access all that information as if request was an object. And that's the beauty of this kind of programming. You can also see that it's maybe a bit clunky here in this code, but it is more readable than PHP. And it's much less code you have to write than in PHP for the same exact thing that I'm doing here. Let's see, manage by, there is a market, there's lots of code, I think over 5,000 lines or so of just Python code. And then you have also these templates. Another cool thing about Django and, or actually PHP as well, Node.js, like Express languages, right? Frameworks, is that they all use templates. And what I mean by that is you can create, for instance, I'm gonna go to base generic. You can create this major big base file. It's like a fundamental file that everything else will be based on. All your pages will be based on. You can see all your pages will always have this title. All your pages will always load these resources, right? All these pages will have a certain structure in terms of, what's it called? Menu. Where is my page? This menu, right? This menu is always the same for every single page. Doesn't matter what page I go to. So instead of copy pasting this on every single page that you're creating, you created one template called base.html. You put all this stuff here that you need to. And then you say at some point that whatever block I want to write as a custom made block that is different per page, I'm going to call it as content block. And I'm going to insert it on line 173 and 174 inside of this template. And all you have to do next to insert stuff inside of this template is to create a new file called, for instance, market admin, and say that at the beginning of this file, I'm actually creating this block content. It ends at the very bottom, right? And block content. And all those almost 300 lines of code will be automatically copy pasted inside of your base generic before getting served to the user. So you don't have to worry anymore about fixing up your menu on one page and then doing the same exact fix on every single other page. You fix it once in the base generic and you're done for all pages automatically. So that's a very nice feature of pretty much any kind of web framework, not only Django necessarily. You can also notice that for those of you who know HTML will notice that there are some tags that don't even exist in HTML. The curly brace and then %. Those tags define, in our case, Python code, or better say Django framework code. by some Python language. And you can see that you can do all kinds of crazy stuff on the fly. You can actually have for loops, kind of like in PHP, they have for loops, right? Let me show you, for instance, here. There's a for loop somewhere. I'll find it, Control F. That's not it. For %. There we go. You can have for loops inside of your HTML page. Similarly, what you can do with PHP or even JavaScript, right? So you can generate all kinds of stuff automatically on the fly. And if you open up Market, for instance, all of this stuff is not manually generated. All I had to do is to say, grab in a for loop, grab, say, 20, what is it? 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah, 20 images, 20 different titles and descriptions and prices, right? And then put them inside of a for loop, inside of a table. And that's it. And then you split it up into pages if you want to, right? So that's the idea. And these prices are generated actually automatically based on the number of coins you have. So currently you have 0, so it's going to be 0 here. But that was the idea for the cybersecurity camps like GenCyber, when the students can play around with the platform, earn their coins, and then at the very end, the admin would actually turn on or enable the market. Currently, I'm showing you the user's access. Admin access actually looks different in terms of what kind of things admins can do. But for the trial version, you only have access to the user accounts, not admin accounts. Typically for admins, you would just make a request and I could easily make you an admin for your own school. So that shouldn't be a problem at all. What else can I show you? I can show you lots of stuff, but maybe some of it will be not that interesting for you guys. So I just wanted to poll some ideas. Any questions so far? Did they bore you to death? Do you want to talk about specific technology? Maybe come back to AWS? You want to explore that? Let me know. Are the challenges customizable? Oh, that's a great question. So to insert bug bounties, I actually had to manually make them. So every single one of them, I had to manually insert a check for a potential attack. Because currently, obviously, I had to write hopefully secure code, even though obviously 100% you cannot write secure code. Nobody can. But I am trying to fix all kinds of bugs on the fly. So I'm making these bug bounties in a sense that you're not going to be able to break the site, quote unquote, because technically there are still ways to do this, right? That's why I had this area, because these people really broke it. Now, I hope that you can't really break the site while you're looking for these bug bounties. But as soon as you found something, I'm going to show you a simple one, the 404 one. If you type in something here, it's going to bring you to a page that will tell you good old 404 and it gives you a code to redeem, right? So this is one of the bugs. And this is a very simple bug to find. I have different types of bugs by the complexity, but still I had to create this manually. So it is customizable, but you have to edit the code. You cannot, you won't be able to say, I want to add another bug and I want to call it this way. This is going to be the text for it without actually editing the code. I hope that answers the question. Yeah, maybe. Any other questions you guys have? So under your features, you have other CTFs. Oh, I see. Yeah. So under my features, I have different things. For instance, the blockchain will keep track of your transactions over time. Whenever you get a bug bounty or earn something as somebody transfers you coins, or maybe just admins transfers you, for instance, if you're running it in a cybersecurity camp, right? Admins can actually transfer coins directly for activities. You can also see those activities right here under activity history. But all of these are not CTFs. The only CTF is bug bounty and reconnaissance. All the other ones are supporting systems that teach people about a specific technology. In our case, it's a blockchain, or maybe just idea of a Hall of Fame, right? Or an idea of some open source intelligence where you can see the list of people who actually found stuff. So that kind of stuff. So these are not relatable to CTF, except bug bounty and reconnaissance. Yes, the idea is to try to break the system. Absolutely correct. That's the idea. And because it was originally designed for the CAMs, the secondary idea was to actually use this as a system to keep track of your digital currencies that people give you for, I don't know, admins give you or teachers give you, right? For doing something good or something bad, I don't know, during your 1 week or 2 weeks in summer, right? And then you can spend those coins in the market. So that's the reason why we have the market, even though there are some bugs here hidden as well. But that was the primary reason behind the market and the primary reason behind the wallet, right? There is no users here, so that's the idea. And then I also have this super admin account in which I can see every single university, or I guess I call it GenCyber room, right? In my case, I created it based on IP address, right? When you do a trial version, it creates it based on IP address. But otherwise, I can create them, I can delete them. I'm going to remove my account, for instance, later on and do all kinds of other stuff, see the statistics for it. So that's also fun. So let me show you some stats while you guys maybe coming up with other questions. I don't know if you guys want to talk about any kind of DevOps stuff. You were ever wondering about setting up your own web server, maybe on Raspberry Pi. We can talk about that as well. So this is super user. All right, there we go. So that's the one I want to show you. So this is this like ultra cool admin account that can access everything and everything. You can see how many users are logged in, how many schools have been using this system so far, how many students, bugs found, blah, 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 blah. And then you can also see, for instance, delete codes, right? That's a useful feature. You can create codes, you can delete the whole school. You can go and check out all this stuff in Django Admin, which is also wonderful. That's a place that is, for instance, right here. This is actually literally a real Django administrative page that Django creates for you. So it has an admin panel, dashboard, all this stuff that you can edit manually. Right? I could go to market item and I could manually edit this microphone blocker right here without doing anything. I did not write this panel, did not write this part of the stuff because Django does it automatically for you. Oh, curious about, okay, there's some questions. Is there some kind of score timeline? Yes, so we do have, let's see, Hall of Fame, in which you actually will keep track of date and time, how many discovered bugs per person you have, and what kind of bugs they actually discovered. And those bugs will also lead to a page where you can, for instance, let me just show you as an example, to a page where you can learn more about that bug. I'm gonna just create access something that doesn't exist, get that stuff, go to wallet, redeem this stuff. And you can see that You learn about this code, you earn 20 GenCyberCoins, you go to Hall of Fame, and you're gonna see this record. Here the time, right? Your name, how many bugs you have, and then what bug it is. You can click on it and learn more about 404 error. The notorious 404. I don't know if you guys watched Mr. Robot. That was a great episode. Really recommend that show if you wanna see real hacking. You know, in movies they never show you real hacking except Mr. Robot. So, and then curious about the possibility of Pi instance. Yes, I believe you can. I have not tried it myself, but I do not see the reason why it wouldn't work. And the reason why I'm saying is Pi instance runs Linux kernel. It can run Python. It's not bad as a Python web server. I tried it multiple times, not necessarily with Django framework, but because Django framework is a part of, it's written in Python, right? It's a language is Python, and Python works on Raspberry Pi, so it should be working. I did use databases before on Raspberry Pi. It worked just fine as well. So I don't see why not. And given that Raspberry Pis, I believe the latest version has what, 2 gigs of RAM? Even 1 gig of RAM should be enough, to be honest, to run this stuff. Yeah, shoot me an email if you want to play with it and try, or if you want to help out with anything like that. You can make a pull request if you figure out how to set it up on Raspberry Pi, and we'll put down your name here. You're going to become one of the contributors. I have a few. Those are just my students. I had another one, but somehow his code got merged. All right, sure thing. And GitHub, by the way, has released just a few days ago, right, for free private repositories for any number of people per team. I'm sure it's probably because of their competition with GitLab, but it's very useful tool to use in universities and even in high schools, to be honest. Especially if you're a student, I really encourage you to look into GitHub and putting some stuff on it. It allows you to keep track of all your code, all your versions, right? You can click on commits and see exactly what time what was done. So if something went wrong, you can always come back and revert, check out the other commit, right? Revert back to something else. You can create branches on GitHub, meaning that if you want to work on a specific, I don't know, fixing bug or maybe adding a new feature, instead of changing something on your production, which master branch is the main branch, you have a spin-off, kind of like in movies. You put it out on the right side, on the left side, you work on it, you messed up stuff, you can break stuff there. Who cares? Because master node is still correct, it's in production, it's working. And if it does work eventually, which obviously rarely happens, code never works from the first time. But eventually, if after all the tests, maybe you did revisions, 1 year passed, you decide to finally add your feature to the master, it's not going to be a problem at all. You just go here, make a pull request to yourself, merge them together, and that should be done. Yes, thanks Gus. He put a GitHub Student Developer pack, which is actually a nice pack. It has lots of nice links to different types of services, which one of them is Heroku. Just because we still have time, I'll show you that one. If you ever want to get your app for free running on the web, you can spin it up in a Heroku container. So you create your Docker container, right? You put your app, you test it all works on your local machine, laptop or whatever, and then you can put it out there for free to run on Heroku.com. And for instance, my Juice Arcadia is running there. This is an app from, I'll show you right now. First, I'm going to run it. And then while it's spinning up, because currently it's suspended, if you don't access your Heroku app for half an hour, it's going to suspend it. So it's going to take about a minute to bring it back up, but it's free. So why not, right? And you can see it has a very nice domain name. And if you want to replace that, you can always buy for free a domain name from Freenom. Great place. Looks sketchy. I'll give it that. However, it is free domain name. And look, people were wearing masks and thought about coronavirus, I guess, even that time already. So anyway, so you can see that you can check availability. I know, you can call anything. I'm sure somebody already took coronavirus free domains, but maybe not. Yeah, everybody took the free domains already for coronavirus. I should have guessed that. What virus corona? Even that is taken. Wow. I don't know what they're running there, but they're running something. It's free domains where you can do stuff. You can see I deployed here a Juice Shop app, which is from OWASP. Great app to learn about web application vulnerabilities. Obviously, it's in Russian. I'm going to switch back to English. Here it is. And I'm going to go to Juice Shop, OWASP, GitHub. There is one button to deploy it for Heroku. All you have to do is create an account on Heroku, click on this button, and you are in. Super simple. It has over 70 different vulnerabilities. It's written in Node.js, it's JavaScript. Again, as much as I hate JavaScript, it's a great stuff, great platform to learn all kinds of web app vulnerabilities. You can see there is a scoreboard in which you have all kinds of challenges from beginners to super, super diabolic. And I'm telling you, those are hardcore. They do have write-ups. They have very nice, it's slowing my Firefox. Huh? So they have very nice challenge overviews. They have hints. You can literally learn it from pretty much about anything else. Oh, come on. Firefox, you can do it. It's not too bad. How's my network doing? My poor Surface Pro probably is struggling with life, as you can see. Don't you love browsers in 21st century? Look at this mess. 94% of memory is gone because primarily I have 3 gigs on Firefox. Isn't that crazy? I don't know what it's doing. I think it's taking a break. It's either a coffee break or a smoke break, but one of those breaks here. Doesn't want to load. But in scoreboard, you would see these challenges. And if you click on Unsolved Challenge, you will be brought to a page where you can see documentation. At the very, very bottom, you have appendix, and that's where you can find challenges. Since it showed, it's refreshed. Okay, GG, bye-bye. All right, that's gone. Well, I think it's 8:58. Shoot me an email, guys, if you want to follow up with anything. And I believe Gus is recording it.
Yeah. So what's your what email can they contact you at, Vitaly?
Oh, sure. Yeah. Just I'm gonna post it on.
Can you say it too for the folks who are recording sessions for?
Oh yeah. You can do FordV, FORDV at Arcadia. That's the school I'm at. It's arcadia.edu.
Sounds great, but
yeah, you can use my vford@cyberstudents.org. That also works.
Well, sounds great. Thank you for the webcast and the presentation. Excellent, really cool stuff that you put together. So we'll be recording this session, put it on our YouTube page. We'll set up a follow email out with a bunch of links that Vitaly was talking about, the link to the YouTube page and the video. And stay tuned next month. I believe our next webcast is May 14th. We'll be sending an email out for that also. So Have a good night, everyone. Stay safe, and thanks again, Tali, for the presentation.
All right. See you guys.